You ever wonder what good quality audio really means? I mean, we throw around terms like clean signal or low noise all the time, right? But how do you actually, measure it? Well, let's dive right in, because today we're going to crack open the very box that puts a hard number on sound quality.
All right, check this thing out. This is a signal quality meter, and it's going to be our tour guide for the next few minutes. Yeah, it might look a little old school, I get it, but trust me, the information it spits out is absolutely fundamental for understanding, well, everything from your hi-fi stereo to complex radio communications. So, what secrets are hiding behind that needle? Let's find out.
Okay, so let's get properly introduced to this little box. Before we can understand what it's telling us, we kind of have to learn the language it speaks. And that means understanding the fundamental measurements it's looking for in any audio signal.
Okay, so first things first. We need a consistent way to measure a signal's strength, right? And that's where something called RMS voltage comes in. See, an AC signal is always bouncing up and down, so just looking at its peak voltage isn't super helpful for figuring out its real power. RMS gives us this nice, steady, effective value. You can think of it as the AC signal's practical, real-world power equivalent. And this is super important because it's the bedrock for everything else we're about to measure.
All right, so RMS tells us about the signal's overall strength, but strength isn't everything, right? It's not the whole story. Now we get to the good stuff, decoding the other dials on this meter. These are the ones that tell us about the quality of that signal. And believe me, this is where it gets really interesting.
So let's talk about SYNAD. This is basically a report card for your audio, a grade for how usable it actually is. Here's a great way to think about it. Imagine you're in a super crowded, noisy room trying to have a conversation. SYNAD is the score that tells you how clearly you can actually hear the person you're talking to over all that background racket. So, a higher SYNAD score, that just means a clearer, more understandable signal. It's really that simple.
And now for the flip side of the coin, THD plus N. If SYNAD is measuring the good stuff, well, THD plus N measures all the bad stuff, all the electronic garbage. It literally tells you what percentage of the total signal is made up of things you absolutely don't want to hear. We're talking hiss, hum, all those nasty little artifacts. So the main takeaway here is super simple. For awesome, high-quality audio, you want this number, this percentage, to be as low as you can possibly get it.
And this table, this lays out that relationship perfectly. You can see they're complete opposites. As your SYNAD score goes up, meaning your signal gets clearer, your percentage of garbage, that THD plus N, goes way down. So, for example, look at a SYNAD of 40 decibels. That's excellent. Only 1% of the signal is junk. But drop down to 12 decibels, and suddenly over a quarter of what you're hearing is noise and distortion. Now, that might be fine for a crackly two-way radio call, but you are definitely not going to want that for listening to your favorite music.
Okay, this chart shows something that's actually fascinating. It turns out distortion isn't always some kind of flaw or mistake. Sometimes it's just baked right into the signal's shape. Look at a pure sine wave. Zero distortion. Perfect. But then look at a perfect square wave. Whoa, almost half of its energy is technically harmonic distortion. It's just part of what makes it a square wave. This is such a cool way to see why creating a truly pure tone is a massive engineering challenge.
So we know what the meter measures, but the real question, the million-dollar question, is how does it do it? I mean, how can it possibly separate the signal you want from all the noise you don't? To figure that out, well, we have to peek inside the black box.
This really is the key, isn't it? I mean, if the meter is just getting one audio stream with everything mixed together, how on earth does it know which part is the good stuff and which part is just static? The answer, it turns out, is incredibly clever.
All right, I know this diagram looks a little intimidating, but don't get bogged down in all the little boxes. The actual process at the heart of this thing is super clever and surprisingly logical. We're about to break it down step by step. This is really the secret sauce of how this whole thing works. So the whole process really boils down to 4 clever steps. First, the audio comes in and gets digitized. Simple enough. Then in step 2, the meter measures the total power of everything. The signal, the noise, the distortion, all of it mashed together. Now here comes the magic trick. In step 3, a special little thing called a notch filter surgically removes only the pure 1 kHz test tone we're sending it. And then, for the final step, with the good signal gone, the meter just measures what's left behind. And what's left? Well, it has to be just the noise and distortion. It's this beautiful, elegant process of elimination. And just look at this graph. This shows you exactly what that filter is doing. See that incredibly sharp dip right at 1000 Hz? It's like a surgical tool, a razor-sharp scoop
that just plucks out that one specific frequency, our test tone, and leaves absolutely everything else untouched. This incredible precision is what makes the entire measurement possible.
Okay, so theory is great and all, but this isn't just some dusty old textbook concept. Now that we know what this meter does and how it works, let's talk about a classic real-world scenario where these measurements are absolutely 100% critical.
You know, one of the biggest uses for a SYNAD meter, especially if you're into ham radio or commercial radio, is testing a receiver's sensitivity. All that really means is you're asking a simple question. How weak can a signal get before the radio can't make sense of it anymore? How good is its hearing, basically? So the first method is called the quieting method, and it's pretty intuitive, just like the name says. You basically start by tuning the radio to a dead channel, just pure static, and you measure that noise level. Then you start transmitting a clean, empty radio signal, and you slowly crank up its strength until that background hiss gets quieted down by a specific amount.
And what's that specific amount? Well, the standard is usually 20 decibels. The moment that background noise has dropped by 20 dB, you look over at your signal generator to see how much power you're using, and boom, that is the sensitivity of your receiver.
All right, now for method number 2, which is the big one, the one that's the standard for pretty much all modern communications gear. It's the SYNAD method. This one's way more direct. You just transmit a signal that has our old friend, that 1 kHz test tone, mixed into it. Then you hook up the meter to the radio speaker or headphone jack and just slowly increase the signal's power until that needle on the meter hits a specific target value.
And what's that magic target? It's almost always 12 dB. You'll see this number everywhere. It's become the industry-wide benchmark. The thinking is, if a radio can pull a 12 dB SYNAD out of a signal, then the audio is clear enough to be reliably understood. So, whatever signal strength it takes to hit that 12 dB mark, that becomes the official sensitivity rating for the radio. Simple as that.
All right, so we've gotten into a lot of the technical details here. But what's the big picture? Let's zoom out for a second and really focus on the one fundamental idea that this whole device is built around.
There's a line that sums this up perfectly. It's that SYNAD tells you how usable a signal is when noise and distortion are both trying to ruin it. And that's it, right there. At the end of the day, it's just a battle. You've got the signal you want, and you've got all this garbage trying to ruin it. SYNAD is just the scoreboard that tells you who's winning. So really, what this all comes down to is this. This isn't just about abstract numbers or cool-looking vintage meters. It's about putting a real, solid number on the idea of clarity. It's about taking something subjective, like good sound, and making it objective. It's all about putting a score on that eternal battle between the audio you want and all the electronic junk you don't.
And that just leaves us with one last question for you. Now that you know how this stuff is actually measured, what's the first piece of gear you'd want to test? That vintage stereo receiver you have? Your handheld radio? Maybe your car stereo? Because at the end of the day, being able to measure something is the very first step to truly understanding it and making it better.